constraint-based sketching, equal distance constraint. So if we have a line, another line, two more lines. Let me first try and move this line. Let me see if I can make it parallel. Well, let's put a constraint on it to make it parallel. So this is the target parallel to this anchor. That's okay. Let me show the constraints. Let me just quickly delete this. Okay. So as I said, equal distance constraint. Now, if I want to make these two lines the same distance apart as these two, this would be the target distance separation, and this would be the anchor distance separation. Now, if I move one line, the other will move. Same with this pair as well, because we have two pairs. So if I hover rather over any of these constraint icons, you can see the opposite pair, the associated pair highlighting. If I now fix one line, what now happens is if I move one curve, as you can see, the curves get closer together. Let me delete these. Let me add a point and a couple of circles. Let me make those circles the same size. So this is the same size as this. I'll add a dimension. Change that to 5. Now I will fix this point here. Now this equal distance constraint can actually apply to, I won't call it a virtual distance, but it's a distance which isn't connected with a curve. So we'll have this as the target distance, and we'll have this as the distance to be copied, the anchor distance. And now when I move that circle in any position, the distance between it and the fixed point is duplicated in the other constraint. Well, it's the same constraint, isn't it, obviously. If you want to see what constraints are applicable, as it's not obvious, if you go to the center, select the center, you'll see a point constraint that comes up. Now, select it to delete if you want, but this is a quick way to actually see what constraints there are. If you go to this menu here, it doesn't actually show you, it just shows that there is a equal distance between those two circles, and it shows that these are also the same size. There's a circular same size constraint. Let me give you a quick example. If I draw a rectangle and offset that rectangle equally with another rectangle, let me change all those internal curves into construction curves. I'll now put circles on the corner of these construction curves. I'm going to show my constraints on now. Now I think they're all the same size. Yes, they're all the same size. Good. Now, if I want these, I mean, it's very typical that holes are related to outside edges or maybe an internal edge of, for instance, it could be a sheet metal part. But you're not quite sure the size. So potentially what we can do to aid the sketch design is add an equal distance constraint. So in this case, I would make this target to be the same as this anchor distance, and this target distance to be the same as this anchor distance, and the same here to be the same as this anchor distance. So what that now means is that if I now change the width or the length of this rectangle, the position of the holes are now linked, constrained to the outer edges. I can now add a size, and just by changing this size to, let's say, 50, you get a change. And also, if I now add a dimension between here and here, if I now change this dimension to, let's say, 6, you get this equal offset all the way around. So that's quite handy. Let me add another dimension to the height. Dimension to the height. Let's change this to, let's hope it's not a square. Let me just check it's not a square. No, I don't think it is. So let me change this to 100. And there you have a constrained sketch acting parametrically. Don't forget, for a quick assessment of what constraints, if you select the curve itself or the end point, but let's go with the curve and let's look at what constraints. We've got verticality, we've got this equal distance between the target and the anchor distance, as you saw. We've got the top end coincident, bottom end coincident, and this dimension. And if I delete the dimension, you will see this 100 disappear, and then you can move that to another place.